introducing the next talk, just extracting the lurking stories behind the numbers. Mr. Steffen Wehrmeier will talk to us about computing numbers with an application to the problems of our society. Please give him a warm applause.
Yeah, thank you. Obviously, this is a reference to a Turing paper. I got many questions, but those of you who got it, thumbs up. And this talk will basically combine computer science and journalism. I'm currently a data journalist. I joined a newsroom about 1.5 years ago. It's called Correctiv. It's a non-profit newsroom based in Berlin. We do long-term investigations, and we are member-based and currently a bit foundation-funded. And we are doing investigative journalism. Investigative journalism, what is that? One good example now from popular culture will be this one. This is the movie Spotlight that just came out in the US. It will come out soon in Germany. And it's the story about child abuse by the Catholic priests in the Boston metropolitan area. And this is the team that basically uncovered it, or rather, it's not. These are the actors that play the investigative journalists. And the whole film is actually quite a good representation of how investigative journalists work. Especially, so this film depicts a story from 2003, 2001, I think 2001. And yeah, it's a bit slightly over-dramatized, of course, because it's like a Hollywood film, but it actually depicts investigative journalists quite accurately. Of course, it also depicts the gender balance quite accurately, as you can see here. But it is getting better. So in Germany, for example, the leading data teams from Spiegel, Bayerischer Rundfunk, and SRF in Switzerland are led by women. And also the organization that represents investigative journalists in Germany has mostly women on its board. So still many investigative journalists, like too many are still men, so women get into the field as well. So the Spotlight team, so what they did is they got a tip and then they looked at data. They collected data about priests who were moving between the different parishes, so the different districts in the metropolitan area of Boston. Every time there was an abuse scandal, they got a sick leave or something similar and got moved to a different district to cover up the scandal and to make it appear that it's just like a single case. The truth would be that they discovered that many more cases were present, and they basically uncovered that it was like a systemic problem. And this is actually one of the core pieces of investigative journalism, that you don't show that a single thing is wrong, like this man did something bad, but that the whole system is set up in a way that many people do many bad things. And so they used books that displayed where priests were moving, like where is the priest in which year, that like a book for every year, and then they went through it and typed it in a computer, and they actually had like a nice spreadsheet in the end which displayed where priests were moving. So investigative journalists and computers are like a perfect match. Of course, computers are used in many other areas of journalism. Every publishing is now, every major newspaper also has a website, of course. There's now robot journalism coming up where sport teams, so sports events are covered by computer programs, not by humans anymore. But what I'm specifically talking about here is investigative journalism, a term that started as precision journalism or database journalism, computer-assisted reporting, data-driven journalism is the current term, and there's also like computational journalism. All these terms basically mean that you use a computer to do an investigative story. And Philip Meyer, one of the first investigative journalists who used a computer, said a journalist has to be a database manager. So we can't quite compare a database admin with a journalist, but it's getting closer. So a journalist has to have its facts. They have their facts, and of course there are too many facts to keep just in their mind, so you have to put it in a computer. And now I will basically present a couple of fields in computer science that investigative journalists use to make their stories happen. One of the big ones is, of course, natural language processing. You know, the Snowden leaks, or if you might remember, the offshore leaks and a couple of leaks that followed. When you have a big leak of data, or you got a big leak of documents, or you got documents via Freedom of Information request, these are like thousands, maybe 100,000, maybe even more documents that you get either in paper form or as PDFs, and what you do with them. You can't possibly read them all. The current newsrooms, they don't have enough staff, they don't have enough time to spend on these investigations, and so they have to use computers to make this job a bit easier. Natural language processing is perfect for that. You just put all the documents you have inside the computer. You have to possibly OCR them, and then a couple of things might work in your favor. So there's entity extraction, of course, that finds out, okay, these documents contain these entities, and so it's not only Mr. Obama, but also President Obama, Barack Obama, and then you can basically extract these entities and know which documents talk about which entities. You can extract who, if, for example, in an email dump, who's talking with who, or also company names. This is like easily is extracted with entity extraction techniques. There's deduplication, there's topic modeling, so you know, okay, these documents talk about these topics, and so I don't have to read them. If I want to focus my story on this specific topic, I go down this path and only look at the documents that are basically automatically categorized in a certain category. And part of speech tagging is often also quite useful when you look at a document, for example, debates. You want to find out who's talking about what in what kind of way. You can find that out with part of speech tagging. And of course, basic search. Search is always quite useful. There are many advanced ways to search, and journalists have to use them to make sense of these big document stacks. Of course, we have document search has been a big part of computer science since like the 70s, 80s. Nowadays we have like Solr or Elasticsearch or other search engines that do that quite easily, but these are made for computer programmers, right? We use them as developers, set them up, configure them, and build our own backend or front end on top so that other people can actually use the search behind it. Journalists have a couple of more they want to use a couple more features in there, and we have a couple of applications that help us there, namely Document Cloud, which is a service where you can upload lots of documents, and they are automatically made searchable, entities are extracted, and then you can also publish them for your readers to also look at them. Overview Docs, which does topic modeling, so you can dive into your documents more easily. There's the project Blacklight, which is basically a Solr front end that you can that I can use to give to my journalist colleagues, and they can use basically a Solr search in an easy way. And there's also, of course, Google Refine, which is usually used for tabular data, but it also has a very good reconciliation backend and also clustering, where you can do deduplication. So if you have like a list of company names and they are like very dirty, you can reconciliate them or basically deduplicate them and make all the company names match again. There's also pro software, namely Nuix or IBM Watson Analytics. They are very expensive, and most journalists have never seen them and or possibly can't use them. It's very difficult to get your hands on them. And that is quite sad because journalists have to rely on these open source tools, which, and there are only a few that are actually made for investigations. And to the computer science part, I'm mostly talking now about basically English language models. It's very difficult to find good German models that are already integrated in some kind of software, so you can use them in the German-speaking world. And that I hope that changes soon. Then there's machine learning, which is mostly used for classification tasks. There's another big field, of course, in the computer science area, in statistical analysis to find out what belongs to which category. And of course, there's a bit of neural net deep learning coming now our way. You can see there's been some deep dreaming in this picture. But I haven't seen like any journalistic piece that has used that yet. I worked a bit on something where I use like neural nets to crack some captures for some databases to scrape them better. But this is still in the making. Here's one story that actually used natural language processing and machine learning in order to identify police reports of the Los Angeles Police Department, which misclassified over 25,000 crimes. So when a policeman comes to or a police officer comes to a crime scene and he writes down a report, it gets later put into a database and then classified by another clerk. And they classify the crime that happened as a minor or serious or another category. And based on the description, the Los Angeles Times wrote a machine learning classifier that looked at basically the description of the crime and a proper classification and trained it on a training data set and then used the whole data set to look if all the other crimes were properly classified, and they were apparently misclassified, over 25,000 of them. And of course, you can't go through all these records and classify them by hand. A machine can do that much more easily. And it has also been confirmed by the police department that there has been misclassification going on. The result is that the crime statistic is much lower and less serious, more minor crimes than serious crimes. And you can basically cover that up through misclassification. And the Los Angeles Times could uncover that through machine learning. Then there's this big field of social network analysis, a favorite topic of Mr. Friedrich Lindenberg, here in this second row. Social network analysis is basically the bread and butter of every journalist's work. We are collecting information about certain entities and we are trying to find their connections. And this is then basically put into, you can put that into a chart like that. So this is like a network graph. The problem with that is the result is mostly not journalism. It's just a research database. You collected some facts, and then you can display them like that. But it's also very subjective data collection because you only basically cover the connections you think are important, and you possibly don't see any others. And it's more like a knowledge management tool where you can collect everything you know to better collaborate with your fellow journalists. But as a result, it might not be journalism. So we can't say, okay, I got this big graph, and now I do an eigenvalue centrality measure, and then I found the bad guy. It doesn't work like that. So you can't like compute the bad guy out of such a graph. What you need to do is do like proper journalism on top. So you have like a knowledge graph, and then you can look at it, and then you can interview people. You can find out more through like proper old school, let's say, investigative work. So what you see in the background is the Lobby Radar, which has been now shut down. It used to be run by the ZDF. And but this is more like a piece of art than gives you an actual insight here. It's difficult to make social networks appear as make them understandable, let's say. And then there's a brand new field of algorithmic accountability, where we also heard, like, for example, the talk about the VW Dieselgate scandal is a topic of algorithmic accountability. More and more algorithms are put into every device we know and making decisions that affect all of our lives. And now we have some hackers that do some reverse engineering, and that is great, and then they present at Congress. But of course, this is basically journalistic work, and we need to bring these techniques into the newsrooms. The newsrooms need to understand, the investigative journalists need to understand how this stuff works and how to reverse engineer it. Nick Diakopoulos, a researcher in Washington, I think, did a lot of work on that. And for example, one thing was stock trading plans of executives that are pre-planned. You can analyze how the plan works and if insider trading is behind it. Or, for example, how does the iPhone autocorrect work? You can observe the output, you can observe the input, what is happening inside. Another example would be how are prices displayed on retail sites for different geographical areas, for example. And analyzing that is not an easy task, but it's becoming more and more important, especially if there's not much transparency around how these things work. So journalism gets closer to science, let's say. The investigations in journalism, they use the investigative method. You also have a hypothesis, like in science. You make up something, like these kids are underprivileged because of corruption going on in the school system. And then you have to prove that hypothesis. And so it's very similar to science. And science also moves now into a more reproducible and transparent manner. The story I told you earlier about the LAPD, this is the code that was used for this story. You have a classifier, a machine learning classifier of a support vector machine, and you can basically run the code yourself to train the classifier and then classify some of these reports. They only publish like a tiny training data set and only parts of the data, but they basically make their methodology transparent. And this is basically also where science is going. Many research papers nowadays are not reproducible, but they should be. And this is a Jupyter notebook, and you can basically create a prose and code mix and then execute it and look at the result. And anybody else can also reproduce your work. So this is Python, but also R are like favorite languages of investigative journalists in the data area. Then one big thing I discovered was that software engineering in the newsroom is not that easy. First of all, of course, there's IT support, and there's the problem of a CMS. So the content management system is always a problem. As a software engineer, you basically always fight the CMS. In big organizations like the New York Times, they basically create their own hacks just so that they can put their beautiful graphics in the rest of the CMS. It's like big hacks going on there. But this is not what I want to talk about. Software engineering in the newsroom is basically also building tools for your fellow journalists. And that hasn't fully, it doesn't have its roots, so software engineering doesn't have its roots in the newsroom. And that's why it's a bit difficult at the moment. Right now, a journalist writes an article, and then it's published, and then you can forget about it. You never touch it again, so there's no technical debt in articles. Code so sometimes code in newsrooms is also written for a single story. So you write code for that story, you publish it, and then you forget about it. But of course, as software engineers, we learn that is not how to do things. We don't want to write the same code again for the next story. We want to have something reusable. We want to fix the bug only once here. We don't want to fix it a million times over all of our articles. And that means we need to clean up a bit and develop some kind of method to write software in the newsroom. It's currently quite a hack as I perceive it. And then computer science papers. I love to read them. They have very interesting ideas, but mostly they don't come with code. And when they come with code, it's not running code. It's difficult to actually make that run. And when I actually compiled that C library to make machine learning a bit faster, it's still not usable software. So I can't give it to my colleague to actually use what I compiled there. And this is definitely something that also, so I hope that when you publish something in computer science that, I don't know, you give me something that I can use to actually bring into my newsroom to make their lives easier. Also, collaboration, which is something that is basically innate to the open source software scene, is a bit more difficult in newsrooms. There's always the competition going on. Especially investigative journalists are used to be perceived as lone wolves. If you are onto a story and someone else has heard of it, you better publish soon because the other guy might, scoop you on it, and then your story is burned and you can't publish it anymore. And all the work you did for that was in vain. Instead, on the other hand, in open source software, it's great if many people collaborate on a piece of software. The higher the bus count is, the better. And so we need to basically bring this idea of collaboration into the newsroom. And this is also still a problem that it is not quite there yet. There are some collaborations now between the New York Times and the Washington Post, for example, or the ProPublica news organization and another bigger publication in the US, I think. And as Correctiv, we also collaborate with many other news organizations that they publish our stories with us together. And we hope that this idea of collaboration that is basically a software idea, as I perceive it, is also coming into the publishing of news stories. And another big problem is that we have some software and we might as well going to use it. And if there's no other software, I can only use what I have. So the hammer-nail problem is definitely something that is in the newsroom. Have you ever seen like a map in some kind of news article with lots of points on them? That's because the journalist that did the story had this mapping tool where they could put in like a bunch of data and then it put it on a map, even though it might not make any sense regarding to the story. They just use the tool that they have. Or for example, a timeline, right? Timelines are also like, there's an easy tool to make a timeline and then you have a timeline, even though it might not be the best way to present your story. It's just the tool that is there, and developing another tool might not fit the deadline or like your resources. So I basically say we need more applications for our society, and many advances in computer science are quite slow to benefit the public at large. If there is like a big jump in, let's say, machine learning, Google knows it first because they do the research, they develop the applications, and other big companies like, I don't know, Palantir, the NSA, or ad companies, they basically use the latest research to do better user tracking or better targeting. And so they benefit quicker from these developments, and so because they do their own research or because they have more resources. Many cutting-edge research comes out of these corporations like Google. For example, recently TensorFlow from Google Brain got released. It's like a machine learning library. There are other machine learning libraries, but this is like one that is very usable, and it is an advantage that it's better supported, better documented, easier to use, but it might not exactly fit the journalistic use case. And so journalism needs more resources to develop their own tools. The tools I mentioned, like Document Cloud or Overview Docs, are quite good. They are basically targeted at journalists. They're developed by journalists, and they fit the use case quite well. But it took like six-figure amounts, as I recall, to develop them over the years. It was very difficult to basically get the use case right. For example, Google Refine, like an invaluable tool to many journalists to work with tabular data and clean it. It's really used a lot. But it was developed by Google and then open sourced, and that basically means it hasn't seen a release in 2 years. And that is kind of bad, that we don't have the resources to basically work on the tools that we use in the journalistic trade every day. So my call to you is support journalism as a service to the public, and help journalists develop the tools. What we have here is basically a public good, journalism. We try to make, we try to be in the service of the public. So, for example, join a newsroom if you can. It's really a fun work. So when I joined the newsroom simply because I think it's basically the best political activism I can do with the most impact. Not only focused on technical topics, we hear lots about data retention and other data topics, but when you work in a newsroom, you get like a very broad range of topics from all over society, and you can still help with data literacy. And another hint, so if you want to get in touch with journalists, there's a thing called Hackers, which is a meetup that is in every big city in Germany. Okay, I think it's only in Berlin and Hamburg. But I think that there's like a data journalism also in North Rhine-Westphalia. But if you're from any place else, like in New York, London, they all have Hackers meetups. Hacks are the journalists, and hackers are, we are the hackers. And they come together there to meet and talk about technology and journalism. And so if you want to have like an idea what's going on in that world, join a Hackers meetup and, improve journalism by contributing your ideas. Thank you.
So I think we have time for questions. We have a question from the internet, please.
Where's the internet?
Hi. The internet is asking many things. And,
Actually,
the most important question is your data mining software available as free software? And please mention some of the names of the tools you have used.
My data mining software. I didn't write a data. So I always did write data mining software, basically, and that is a problem. For every story, you write like a script that does it, and that has advantages because you can customize it. It has disadvantages because you have to write the software, and it's not quick and easy. For example, we in our newsroom, we publish all our work on GitHub at github.com/correctiv, and you can have a look basically at software that is there. Mostly it's just front-end stuff, but we will also publish more basically back-end data, so data analysis pieces in the future. And many news organizations have repositories on GitHub that explain how they do their stuff, and you can find their software there. And the other question was tools or something. So I mentioned TensorFlow is a machine learning library, but there are like many tools for journalists that are mostly, they're not tools that are more libraries. So I'm using Pandas for Python, but there are also a lot of R packages that you can use for data analysis. But the problem is that nerds are a minority in the newsroom. And that means that if you want your journalists to use these tools, use these techniques, you have to write tools to make them usable for like the normal people.
Yeah. Thank you. For the normal people, okay. Thank you. Not that nerds are not normal people, but yeah. We have another question from here, please.
Thank you very much. You've been talking a lot about language processing tools, machine learning tools. And all of those, of course, are known to fail, to produce errors, to classify. That's the word, yeah. And even if they classify correctly, it's not always easy to see what the classification actually means. You alluded to that shortly when talking about graphs and saying you don't only look for the central person in a graph and that's the bad guy. So how do you deal with that risks, with misclassification, with and also the illusion that the data could provide you some knowledge or insight that actually is not in the data, or only apparently is there?
cross-checking, like normal cross-checking you do with data, like check your data before you put it in there for certain things. Quartz recently published a long list of how you interview your data to make sure it's up to a certain standard, or that you're at least aware of its failures. Many times already the input data is flawed in many ways. And then your methodologies, of course, double check it, talk to experts that know more about this field than you do. And by publishing the methodologies, you basically make yourself vulnerable, but also transparent. So if there's something bad going on, your readers or any other interested party can basically run what you did and then tell you about what you did wrong. So any of these machine learning things does not live the journalistic. So as a journalist, you still have to validate your findings through like second means, or at least do a check on a bigger sample. So definitely the result is not coming out of the computer. The result is coming out of the human mind. So the result of a research is not basically the output to stand it out.
Thank you so much. I think we are all done now for the minutes we had for questions. Thank you so much. Thank you, everyone.